Have you ever wondered why light change direction as it passes through the boundary between two media? Have you ever asked yourself what causes light to change direction? What is responsible for the deviation or the change in the direction of light as it moves from one medium to a different medium? In this video, we're going to see and understand what is responsible for the deviation of light. The deviation of light is actually what we refer to as refraction in physics. Okay, let's look at this. Look at this red light that is coming from a medium to a medium. Now, from what I'm seeing here, you can see that as the light passes through this boundary, this horizontal line is a boundary separating two media. Okay, but the media we have here, the first medium is air, so the second medium is also air. You can see that nothing happened to the light, it went straight, it didn't deviate because these two media are the same. We have air in medium 1 and air in medium 2. Okay, so if we measure the angle of refraction and the angle of incidence in this situation, if I place my protractor like this, I'm going to see if you measure the angle of incidence from 0 towards the left, okay, you are going to get 30, 40, 45 degrees. So the angle of incidence is 45 degrees. If you also measure the angle of refraction is the angle made by the refracted ray between the refracted ray and the normal. If I measure from the normal downwards towards the refracted ray, I'm still going to have 45 degrees. So since the two media are the same, they have the same optical density, there is no deviation of light. The angle of incidence is the same thing as the angle of refraction. So if we apply Snell's law to find the refractive index of the Snell's law states that the refractive index of a medium is given by the ratio of the sine of angle of incidence to the sine of angle of refraction. So if I do that, my incident angle is 45 degrees, my refracted angle is 45 degrees. So if I do sine 45 over sine 45, I'm going to have 1. So these two media are both air. The refractive index of air is 1. Okay, now let's change the second medium to something else. Let's say I change the second medium to water. So the medium we have done is water. You can see that this light ray that came from air passed through the boundary, the horizontal line, entered the second medium water, didn't continue going straight. You can see there is a deviation now. The angle of incidence is still kept at 45 degrees. Then let's see what happens to the refracted angle, which is the angle the refracted ray makes with the normal. So if I look at this, I do measurement. So let's measure from this normal towards the refracted ray. So if I do that, I'm going to have 10, 20, 30. This is going to be about 32 degrees. So the refracted angle is 32 degrees. Let's apply Snell's law to find the refractive index. If we apply Snell's law to find the refractive index, so we use sine 45 over sine 32. So if we do that, I'm going to have sine 45 degrees. You divide it by sine 32. So sine 45 degrees divided by sine 32 degrees. 32 degrees. And that will give us 1.334. So the refractive index of the second medium, which is water here, is 1.334. Now the question is, what made this ray of light to deviate? What made this ray of light not to continue going straight? The reason is because of the difference in the optical densities of the two media. The light ray deviated, changed direction in the second medium because the second medium has a different optical density from the first medium. Now, if a medium is denser, if the second medium is denser than the first medium, the refracted ray will go towards the normal. That is why the refracted ray, the light that entered the second medium water here, is bending towards the normal. Okay, so let's also check what happens with glass. I've changed the second medium to glass. Let's see, you identify that there is more deviation because glass is far more denser than air. That is why the refracted ray in glass is moving closer to the normal. So if a second medium is denser than the first medium, the refracted ray goes towards the normal. So there will be more deviation. Now let's get the angle of refraction. Remember, our angle of incidence is still at 45 degrees. So let's get the angle of refraction. Remember, the refracted angle is angle between the refracted ray and the normal. And from what I'm doing here, if we measure like this, we're going to see that this is 10, 20, 25. This is about 28. This is about 28. So we're going to do sine 45 divided by sine 28. Sine 28. And that will give us 1.50 or 1.51. So approximately 1.51. So what are we learning? That the refractive index of this glass is 1.51. 1.51. So in this video, you've learned that the denser the second medium in which light has to pass through, the more the deviation, the more the change in the direction of the travel of the light ray. This is what we call refraction of light. Stay tuned for the next video, which is going to be on the reflection of light. Subscribe to my channel to watch the next video, which is going to be on the reflection of light.